Welcome my dear learners for this course on engineering graphics. In this module 4 we were discussing on development of lateral surfaces of solids. So far we have solved 8 problems on development of lateral surfaces of solids. Moving ahead, the problem number 9 states that a regular pentagonal pyramid of side of base 35 mm and altitude 65 mm has its base on HP with a side of base perpendicular to VP. The pyramid is cut by a section plane which is perpendicular to VP and inclined at 30 degrees to HP. The cutting plane meets the axis of the pyramid at a point 30 mm below the vertex. Obtain the development of the remaining part of the pyramid is the question. Now first let us draw the front and top view of the given problem. So if I draw the front and top view, first let me take the reference. Always draw the top view first and then extract the front view for a solid which is resting on HP. Now I cannot draw pentagon, however I require, because he is clearly stating that a side of the base is perpendicular to VP. So first I will draw a side of a pentagon which is perpendicular to VP. So for VP, first I will draw a side of the base and make it perpendicular. The base side is 35 mm. So I'll draw a side perpendicular to VP first. I'll draw a side perpendicular to VP first. Keeping this as reference, I will complete the pentagon. For pentagon, you know, the side angle is the interior angle of a pentagon is 108 degrees. So mark 108 degrees interior angle as 108, 72 exterior, 108 interior, 108 interior or 72 exterior, and then you draw the line for the required dimension. The dimension is given for us, that is 35 mm. Here also I should draw 35 mm. Drawn. Now use compass, measure the same dimension and cut arc. From here also you intersect this. So that completes the required pentagon of dimension 35 mm side, and one of the side is perpendicular to VP. Satisfied. So this side is perpendicular to VP. Now find out the center of this pentagon by drawing perpendicular bisector from each corner to its opposite edge. So I'll take one more from here. And mark it as O1 and call it as A, B, C, D and E. The dimension of this is nothing but 35 mm, which is given in the question. We have drawn a pentagon of side 35 mm. Show that in the top view. So side length is 35 mm. Done. Now take the projection and complete the front view. So first I want the axis. I'll take the projection of the axis, and then I'll take the projection of all the corners. Now first I lay down the axis. The altitude is 65. So draw the axis first. Axis height is given as 65. Drawn. Axis height is drawn, and show the axis height from HP, which is at a distance of 65. Mm. The cutting plane meets the axis of the pyramid at a point 30 mm below the vertex. So measure 30 mm below the vertex. Keep it as a reference, because here the cutting plane makes an angle of 30 degree to horizontal plane. So this dimension is also specified from the top. It is specified from the top. We have measured from the top as 30 millimeters. Done. So now lay down the slant edges. Lay down the slant edges. This is the required front view of the pentagonal pyramid. This is O1 dash, O dash. Here A dash is visible, E dash is invisible. Here B dash is visible, D dash is invisible. Here we have C dash. Now at a distance of 30 on the axis, draw the reference where the cutting plane intersect the axis at an angle of 30 degree to HP. Now lay down 30 degrees to HP. Using protractor, mark 30 degrees to horizontal plane. Mark 30 degrees to horizontal plane. Now lay down the cutting plane. Lay down the cutting plane. Select the cutting plane. So this is the cutting plane, making an angle of 30 degrees. It is making an angle of 30 degrees. Now if you carefully observe, the slanted OC is parallel to VP. So therefore C dash O dash will give us the true dimension of the slant edge. So no need to rotate any of the edges, because the slant edge OC is parallel to VP. So therefore C dash O dash is the true dimension of slant edge. So make use of O dash C dash to complete the development. Measure O dash to C dash. O dash to C dash is measuring 71 millimeters for me. So this dimension is measuring 71 mm. I'll take this as a reference, using which I can complete the development. So this dimension is 71 millimeters. Done. Now transfer all the points to this true slant edge. First, if you carefully observe, none of the base edges are affected. If any of the base edges are cutting by the cutting plane, then I should measure the dimension from the top view. Since none of the base edges are cutting by the cutting plane, no need to worry, just check for the slant edges. First slant edge is AO, that is A dash O dash, mark it as 1 dash. Next move for B, B to O is here, B to O, take it as 2 dash. Next C to O is 3 dash. Next D to O is 4 dash, which is invisible for us, 4 dash. And E to O is 5 dash. 5 dash. Now mark these because this is a pyramid. From all the corners draw a sharp dark line to the center, which means to say the slant edges are visible in the top view. Because this is a pyramid. Done. Now transfer all these points to the true slant edge. So 3 dash is on the true slant edge, leave it. 2 and 4 you transfer. 2 and 4 you transfer. Transfer 2 and 4 and mark it as 2 dash 4 dash. 2 dash 4 dash. This is nothing, just to show the inclination at distance of 30. Axis is nothing. Axis is of no use, don't worry about that. Here for marking points, it is important to lay down the cutting plane. 2 dash 4 dash, and then here we have 1 dash 5 dash. 1 dash 5 dash is now transfer 1 dash 5 dash to here, because AO and EO are not parallel to VP. So transfer 1 dash 5 dash to the true slant edge. This is 1 dash 5 dash. Now just by using O dash C dash complete the entire development. Now first draw an arbitrary arc for unknown angle of radius 71 mm, that is measuring 71 mm from here, measuring 71 mm, you draw an arc. So draw an arc. This dimension is not known for us. Now if I cut it from one of the slant edge and unfold, I will get 5 triangular faces, correct? Because it's a pentagon. Each of base 35 mm. So therefore measure the base 35 mm. Measure the base 35 mm and transfer. 1, 2, 3, 4 and finally 5. For which I want the extension 5. Now connect these things. That is, this is A, B, C, D, E and A. So join OA, OB, OC, OD, O to E, and finally closing side is same as this starting side, that is OA. Done. So this dimension is how much? 71. We know that this dimension is 71 mm. Oh. Right. Now since this is a pyramid, we will get sharp base edges, it is not curve. So connect A, B, C, D with sharp edges at the bottom. Done. Now lay down the points, that is using compass you measure. 1 and 5 are same, 1 and 5 are same, no need to worry. So just you transfer. 1 is at the beginning and at last, 1 and 5. Here also I require 1. So this is 1, 1 and 5. Next we have 2 and 4. 2 and 4 is here. 2 and 4. That is OB is 2, OD is 4. So this is 2, this is 4. Then we have 3 on OC, on O to C, lay down 3. Now connect these points 1, 2, 3, 4, 5, 1. That is 1 to 2, 2 to 3, 3 to 4, 4 to 5, then 5 to 1. Now you connect 1 to A, 2 to B, 3 to C, 4 to D, 5 to E, and 1 to A. And these things should be removed. So this is the development. This is the development of the given problem. This is how we should solve development of pyramids. We have solved development of regular pentagonal pyramid for which the cutting plane is inclined at an angle of 30 degrees at a distance of 30 mm from the vertex meeting the axis. Since OC is already parallel to VP, O dash C dash is the true slant edge. No need to worry. If this pentagon would have been inclined at certain angle and none of the slant edges in the top view are parallel, then I should make any one of the slant edge parallel and take the projection, use that as a reference and draw the development. The difficulty is not present in this problem because O to C is parallel to VP, so therefore O dash C dash is a true slant edge. Transfer all the points to O dash C dash, using O dash C dash complete the development. This is the solution of problem number 9 that's solved from this lecture. Thank you all.